welcome you all to my channel Infotainment and to the playlist of digital signal processing. In this video, I will be showing you the Twiddle factor representation of DFT. Let us see the Twiddle factor representation. In the case of Twiddle factor representation, I represent the Twiddle factor as W, which is equal to e raised to the power minus j2 pi. Fine. Now, we have the term e raised to the power minus j2 pi in our DFT formula as well as IDFT formula. Let us see how it is represented in the case of DFT formula. Now, since W is equal to e raised to the power minus j2 pi, since I introduce k and n terms over here, let us see how to represent it. E raised to the power minus j2 pi, which represents W, k n divided by capital N. This is equal to W. I represent capital N in the subscript, small k n in the superscript. Fine. So capital N in the below and small k n above. So this is the basic representation of the Twiddle factor. Here you can see a minus sign which is present. This minus sign is generally missed because here in the subscript, here in the superscript, you don't get the minus sign, but because W is equal to e raised to the power minus j2 pi, so here it is just a plus sign which is generally missed. Now let us see how this can be written in the DFT formula. X of k is equal to summation n varied from 0 to capital N minus 1 x of n e raised to the power minus j2 pi kn divided by capital N. Now, in the place of e raised to the power minus j2 pi kn by capital N, I would be writing the Twiddle factor W capital N kn. Fine. So, this is how the Twiddle factor representation is made. Now, the same thing can be represented in terms of the inverse of DFT as well. X of n is equal to 1 over n summation where k summation over k ranging from 0 to capital N minus 1 capital X of k e raised to the power j2 pi k n by capital N, and here you can observe that here you have minus sign, but here there is no minus sign, hence it is W minus kn capital N. Here there is no minus sign. Here in the case of inverse of DFT you get the minus sign. Now let us see the matrix representation of the Twiddle factor. Generally the Twiddle factor, that is W kn capital N, which is equal to e raised to the power minus j2 pi kn divided by capital N. The matrix representation of the Twiddle factor for capital N is equal to 4 is given by, the way of representing is very simple. It just has 4 rows, 4 columns, so it's a square matrix. Okay, I just write ones over here, then 1 minus j minus 1 j, then 1 minus 1 1 minus 1 1 j minus 1 minus j. So this is how you would be representing the Twiddle factor for n is equal to 4 in the case of computation of DFT. If you are computing IDFT, then just a small change wherein the minus which was here will be removed and minus will be introduced over here, and the minus which was here will be removed and the minus will be introduced over here. So that means if you remember one of the matrix, that is the matrix used for computation of DFT, the other can be easily obtained by making just the slight changes of the minus signs. Now that we know the matrix representation of the Twiddle factor, let us see the matrix representation of DFT and IDFT formulae. In the case of DFT, the matrix representation goes like this. X of k is always equal to WKN, and the capital N is 4, and the other would be X of n, which is the input signal in the time domain. Similarly, in the case of IDFT, the thing remains very simple. X of n, which is equal to 1 over n into W minus Kn capital N. Here n can be 4, and the other matrix would be X of k. So this is the matrix representation of DFT and matrix representation of IDFT. The general mistake what we make is we forget to put this 1 by n, which has to be taken care of. Thank you very much for watching the video. Hope you have found it informative. Please press the like button if you have liked the video. Then share it with your friends so that they can also learn. Then please subscribe to my channel if you haven't subscribed yet, so that you will be notified whenever I upload my videos in the future. Thank you.